All right, good day everyone. Now, over the past few videos, we've been working primarily with atomic vectors. And while there are situations where a single vector constitutes the only data that needs to be analyzed, it's more often the case that you're working with observations across a range of different variables, and each of those variables really requires its own vector. Consequently, really, for the purposes of staying organized, it's almost always helpful to keep all of these variables stored as a single object. And in R, there's kind of a variety of ways you could go about this. You could store your data as a table, you could store your data as a list, you could even store it as a matrix if you wanted. These are all unique classes of objects that R recognizes. However, for most use cases, a data frame is going to be the preferred method here. So in its simplest terms, a data frame is really just a spreadsheet. It's just a spreadsheet where rows represent observations and columns represent variables. So to kind of illustrate, you might imagine a hypothetical experiment that has maybe two groups. Let's say you have a control group and an experimental group. And let's suppose you have 10 observations in total. So we can actually build a data frame to kind of represent this. So we could start by just um, creating a vector called subject here. And this will just be the numbers 1 through 10. So these represent the different subjects in our experiment. Then what we can do is we can create another vector that just contains our group categories. And we can use the repeat function here that we learned about to just limit some of the typing that we can do. So we can create an object called group, and then we'll use our repeat function. And inside the repeat function, we'll input a vector using the combine function here. So we'll put two elements in this vector. So first element will just be exp, which is just short for experimental group. And we'll put control, which will be short for control group. And then what we'll do is we'll just repeat that vector 5 times. So just to sort of illustrate, or just to sort of see what we've done there, you can see we have just a vector of 10 items, experiment, control, experiment, control, experiment, control, etc. So let's maybe get rid of that. And what we can do is we can create one more object here. We'll just call it value. And value will just represent kind of the measurements that we took for each subject. So we'll just kind of input random numbers here. And I've already selected 10 random numbers, so I'll just paste them in. And critically, what I've done here is I've made the 9th value here to be just a missing value. So that's why it's NA. And I'm just kind of doing this for illustrative purposes. Next, we will run all of that, and then we'll type a new function we've never used before. And that function is data.frame. And what we can do inside this function is just input the names of these objects that we've created. So we could say subject, group, and value, like so. And if we run that, you can see in our console window, we get kind of all of our values here in this nice spreadsheet structure. And what we can do is we can, of course, store this as an object, like so. And now if we just run df by itself, you can see it has that nice kind of spreadsheet style there. Now, when creating our data frame here, there is a slightly simpler approach that we could have taken. What we could have done instead is type our vectors as separate arguments in the data frame function itself. So for instance, let's clear the console. What we could have done is we could have typed something like data.frame, and then inside the function here, we could just literally insert our vectors as arguments. So we could say subject is equal to 1 through 10. And because this is an argument, we have to use the equal sign here. And then, you just put a comma to separate your arguments, and then you would insert group, right? And we have to use the equal sign there, put another comma to separate our arguments, and then we'll grab that, and we'll insert that like so. And now when you run this, what you'll see is we get the same data frame. So that's just another alternative method, and in some respects, it's a lot more elegant. Now, strictly speaking, you would almost never input your data into R in the manner that we've done here. That is to say, in most cases, you're never going to manually type in your values. However, just the basics of constructing a data frame is a pretty essential piece of knowledge, and you'll frequently need to appeal to it when working with R, because oftentimes you'll want to create a data frame using kind of existing variables just to kind of keep yourself and your work organized. Now, a critical feature of data frames that really separates them from kind of traditional spreadsheets is the fact that every single column in your data frame has to have the same number of items as every other column. So in our example here, the subject column, right, and the group column and the value column, they all have 10 elements. That is to say, they all have 10 rows. And note that the missing value here is also counted as an item. In most cases, if you try and build a data frame with columns of unequal lengths, R will produce an error message. And we can actually kind of easily demonstrate that. So for instance, we'll just create a new data frame here. We'll just call it df_2, say data.frame, and we'll create a column called A, and A here will just be equal to the numbers 1 through 4. Then we'll create another column, B, and B will be equal to the numbers 1 through 3. So critically, you'll notice A has 4 items, B has 3. And now when we run this, you can see it just spits out an error. Arguments imply differing number of rows, and that's because A implies 4 rows, B implies 3 rows. In other cases, if you have an unequal amount of values in your columns, and R determines that it can evenly repeat a sequence, R will actually automatically recycle that sequence. So for instance, what we could do is we could copy this and make a third data frame, right? And where we have B here, what we can do is we can just set that to 2. And we'll run that. And you'll notice there's no error this time, which is pretty interesting. So let's see what's happened here. So we'll say df_3. You'll notice instead of producing an error, R just literally recycled the contents of B. So it repeated it basically. So it went 1, 2, and then since there was nothing else to fill this and it could evenly repeat these, it just went 1, 2 again. Now, similar to how vectors can be indexed using square brackets, we can also index data frames. So if you just kind of go back to our original data frame here, let's do this maybe. Let's go a little farther. All right. Looking at our data frame here, suppose you wanted to isolate maybe the value in the 5th row of the 3rd column. So this value right here, 657. You can actually pretty easily accomplish this in the following way. You basically just type df, like so, put some square brackets, then you type the row that you want. So in this case, we want the 5th row, and you type the column you want. So in this case, we want the 3rd column. And when you run this, you can see you get 657. So notice the number on the left side here refers to the row, and the number on the right side of this comma refers to the column. So we have the 5th row of the 3rd column. So in this situation, what we've done is we've isolated a single value, but we can actually select more than one value and more than one column if need be. So for instance, we could isolate rows 1, 3, and 5 from just columns 2 and 3 specifically. And the way you do that is pretty simple. Basically, you use your square brackets again, and then we'll use our combine function, and we'll just select the values 1, 3, and 5. And then outside of the combine function, we'll put a comma, and we'll select the columns we want. So we want columns 2 through 3, like so. And again, everything on the right side of the comma represents rows. Everything on the left side of the comma represents columns. And then when we run this, you can see we get rows 1, 3, and 5, and we get columns 2 and 3, which are the group column and the value column. If you wanted to keep all of the columns visible while only looking at rows 1, 3, and 5, you can do that as well. All you need to do is leave the left side of the, leave the right side of the comma blank. So for instance, just use your square brackets, use our combine function, say 1, 3, and 5, and then put in the comma and just leave it be. And then when we run that, you can see it preserves all of the columns, but it only shows us rows 1, 3, and 5. And a similar logic, of course, applies to rows. A similar logic applies to rows. So we could say comma, and then just type the columns we want to keep. So we'll say 2 to 3, run that, and you can see it keeps all of the rows, but it's only showing us columns 2 and 3. Now, there will also be many circumstances where you need to work with the values of a single column only. So for instance, if you want to calculate the mean of the third column, which we've labeled value here, what you can do is you can use a $ to isolate that particular column. And the $ is a special type of operator in R that is used for subsetting. So let's maybe just clear our console here. And let's sort of illustrate this. So if we type our object name, which is df, and we put a $, you'll notice RStudio instantly brings up this nice little window that has the names of our columns. And if we want to grab the value column, we can just literally select that using our arrow keys, hit enter, and it types it for us. And now when we run that, you can see we get all of the values in the value column. And now that we have those values, we can just insert them into the function for calculating the mean. So we could say mean df value, like so. And you can see it spits out an NA value because there's an NA in our vector here. So what we need to do is we actually need to specify the argument na.rm is equal to true, just like we learned about. And you can see we get the value 339.444. Alternatively, instead of using this $ operator, what we could have done instead is we could have used double square brackets to specify the column number we want. So what we could have done instead is we could have typed df, put some square brackets, and then put some more square brackets inside those. Type the number 3, run that, and you can see it spits out the entire column of values there. You can also type the name of the column as well inside those brackets. So if we say df square brackets, and then we type value, you can see that does the same job. And of course, you can isolate a single column using kind of the row and column indexing style that we described earlier, right? So we could just type df, put some square brackets, put a comma, and then type the number 3, run that, and you get everything. And similarly, you could just type value like so. And that works just as well. Now, one thing that's kind of interesting is that all of these different methods of isolating a column in your data frame have essentially simplified the type of object that we're working with. So for instance, when you subset some values from a data frame, like we've done here, you might assume that the subset of values is still understood by R as a data frame, but they're not. So when you subset in the way that we've done here, R actually automatically transforms that subset into an atomic vector. However, if you want to preserve that subset as a data frame, then what you can do is you can actually just set an argument called drop to be false. So for instance, let's do this. Let's grab just the value column. So we'll just grab the third column, and what we can do is we can add an additional argument here called drop and just set that to false. Then when we run that, you can see we have our output as a data frame. So in other words, the column name gets preserved here. Now, in most scenarios, the existence of this drop argument is not something you really need to concern yourself with. In other words, you're not going to find yourself using this argument all that often. However, for more nuanced programming, it's quite often beneficial to subset a data frame and have that subset still be a data frame that preserves your original column names and row names. And you'll quite often see people using this drop argument in their code. So it's good to know what it's doing. But now that we've learned how to build a data frame from scratch, how do you do something like add a new column to it, for instance? So suppose, for example, we wanted to create a column named alpha that contains the first 10 letters of the alphabet. How would we go about doing something like that? Well, the first thing we would do is we would type, obviously, name of our data frame object here. Then we'll put a $sign and we'll type the name of our new column. So we're going to call this new column alpha. Then what we do is we use our assignment operator and provide a vector of 10 items. And it has to be exactly 10 items because our data frame here has exactly 10 rows. If our data frame had 20 rows, we would need a vector of 20 items. So the thing to always remember about data frames is every column needs to contain the same number of elements. If for some reason, you can't do that, then you're going to need to make sure you incorporate NA values. So what we could do is we could use the letters vector that we learned about, and we could just grab the first 10 letters like so. Run that, and you can see we have a nice new column called alpha, and it gives us the first 10 letters of the English alphabet there. To kind of further illustrate this process, suppose we wanted to create a new column called, I don't know, new value or something like that. And let's suppose this new column multiplies all of the numbers in our value column here by, let's say, 100. So we can pretty easily do that by just kind of using the same basic strategy of creating a new column name, using the assignment operator, and then basically doing some math. So we type df, use the subset operator, type the name of our new column, which we'll just call new val, use our assignment operator, and we'll subset the value column and just multiply it by 100, like so. And now, if we take a look at our data frame, you can see we have a brand new column called new val that just literally multiplies all of the elements of the value column by 100. And of course, 100 times missing is still missing. Now to remove a column, there's kind of a few options you have. So let's assume you want to remove the alpha column that we created. What you can do is you can literally just set that column equal to a null value. So a null value just means that something is undefined and therefore doesn't really exist as an object in the R language. So if we go df, type our $sign, select alpha, use the assignment operator, and then in capital letters type null, run that, and now if we look at our data frame, you can see the alpha column is completely gone. If you want to remove multiple columns, a quick way to do that is to simply index the columns you don't want to keep and then negate them with a minus sign, which means you're now technically indexing the columns that you do want to keep. And then you can just simply override your data frame object, which in our case is just df here. So to sort of illustrate, what we'll do is we'll remove columns 1 and 4. So we'll remove the subject column and we'll remove this new val column. So say df, like so, type df, use our square brackets, we'll keep all of the rows there, then we'll say minus, use our concatenate function, and then we'll just say 1 and 4, like so. So we'll run that, and now you can see we are left with just 2 columns. But what about rows? How do we add rows? Well, to add a row to an existing data frame, the conventional strategy is to use the function rbind. So that's rbind, like so. So rbind here is just short for row bind, and it does more or less kind of what it says on the box. It binds, that is to say, it combines data frames by their rows. Now, in our present data frame, we only have two columns, right? Because we've kind of removed some here. So we have the group column and the value column. That means that any additional rows we add to this data frame can only have two items in them. So what we'll do first is we'll create a very small data frame that just represents the new row that we want to add. And critically, we need to make sure that this new data frame contains the same columns as our old one. So we'll just create an object called new row here. We use our data.frame function and create a column called group, and we'll put spam here. And then we'll create another column called value to match our original data frame. And here we'll just type the number 999. Yeah, okay. So we have our new row. And now what we can do is we can use the rbind function to append it to the end of our current data frame. So say df, say rbind, say df, and new row, like so. Run that, say df, and you can see we now have spam and 999 there. Now, if you want to remove specific rows, you would just follow basically the same process outlined for removing columns. So let's kind of illustrate this. So as an example, let's remove rows 9 and 11 here. So what we'll do, we'll say df, we'll use our assignment operator, type df, and we'll just subset this accordingly. So we'll use our combine function, and we're going to say we want to remove rows 9 and 11, and we'll put a comma, and critically, we have to remember to put a minus sign in front of the function there. So we'll run that, and now when we look at our data frame, what you can see is rows 9 and 11 are completely gone. But notice something interesting here. By removing row 9, that is to say, by removing the row that actually had the missing value in it, the index numbers on the leftmost side of the data frame's output here are now mislabeled. So you'll notice it counts from 1, 2, 3, 4, 5, all the way to 8, and then it kind of skips 9, and it goes straight to 10. And the reason it does this is because these numbers that we're seeing here on the left side are not actually index values, as you might kind of reasonably assume. They're actually row names. And when the data frame was originally created, the rows were quite literally named 1, 2, 3, all the way to 10. So the consequence of this is that when you subset a data frame and you remove a row or potentially rows, you can see specifically where the removal has happened. In other words, this kind of gives you a nice visual confirmation of what specific rows have been removed. The drawback to this, though, is that it makes kind of future indexing potentially a bit more confusing, because now the row named number 10 here is actually the 9th row. So for instance, if we just index this, right, we say 9, and run that, you can see row 9 is actually named row 10, which is, a bit odd. For this reason, it's quite often helpful to rename the rows after you subset or remove certain values. And you can do this pretty simply by just using the row names function. So let's illustrate this. So we'll say row names, and if you input your data frame into this, what you'll see is it will spit out the names of all of your rows. And then what we can do is we can actually use the assignment operator to rename these. So what we're going to do is we're going to say 1 to n row, and then inside this function, we're just going to put our data frame like so. So we'll run that, take a look at our data frame, and now you can see it is named 1, 2, 3 all the way to 9. So there's a nice logical sequence here. Now, you'll notice I've used this function nrow here. And I've used this function to kind of create the sequence of numbers. So if you're curious what this function does, it just simply counts how many rows are in a data frame. So if you type nrow and you insert your data frame into that, you run it, you can see it spits out 9 because there's 9 rows in this data frame. Now, alternatively, instead of writing the code like this, what we could have done instead is we could have said something like row names df, use our assignment operator, and just typed 1 through 9 like that. That would work as well. However, I would strongly advise against doing something like this. The reason being that, number one, if you're working with a really large data frame, you quite often don't know how many rows you actually have. And number two, if it happens that in the future some aspect of your data frame changes, maybe because you've updated your data set or maybe you've indexed different values, this 1 through 9 statement is no longer going to be accurate, and it might potentially produce errors that you may or may not notice unless you've remembered to, update this little line of code here. So if you use this code that we wrote up here, this 1 through nrow df, your row names will always be correct. You don't have to worry about potential errors cropping up if your data set happens to change. Now, we've technically named our rows using numbers here, but you can actually name your rows anything you want. So for instance, what we could do is we could say row names df, and we could say month.name. And we could grab just 1 through nrow df like so. Run that, take a look, and now you can see our rows are just named the names of the month. Kind of silly. And hopefully this goes without saying, but generally speaking, this isn't something you should be doing. If you want to label each row with the name of the month, what you'd be better off just creating a new column in your data frame called month and keeping the row names just ascending integers. And of course, column names can be renamed in a similar fashion, just using the column names functions. We'd say call names, and if you type df, you can see it tells us what those column names are, and of course, we can rename them if we so choose. So we could say spam1 and spam2. How about that? Spam2. And now, if we take a look at our data frame, the columns are now called spam1 and spam2. Now, it's worth mentioning, you can name your columns using numbers if you so choose, but I would advise against that just because it makes subsetting your columns a bit trickier. So for instance, let's do this. If we type something like call names and we rename these to just be 1 through 2, for instance, and we run that, we take a look at our data frame, you can see our column names now are just 1 and 2. But if you want to subset this, you can't just sort of straightforwardly say, like, let's say you want to subset the second column here. You can't just straightforwardly do that. You can see error, unexpected numeric constant in df $2. So what you need to do in this situation is you need to use the grave symbol, or as some people call it, a backtick. So you basically put a backtick in front and behind the number 2 here. And if you're curious where this little backtick symbol is located, it should be right below your escape key on most conventional keyboards. And now, when we run that, you can see we get column 2 subset quite nicely there. And that's the basics of data frames. Admittedly, there's actually a lot more we could discuss here, so we've really only scratched the surface of subsetting in particular. A lot of the times you'll need to subset your data frames in kind of much more complex ways than what we've gone through here. And we'll discuss some various methods for doing that in later videos as the need arises. But for now, as a kind of, if you're like a novice with R, this should be good to set you on the right track.